Hello everyone. Okay, so I'm up to question 2 of the exam 2005 exam paper, and this 3 unit as I was doing before. Okay, so let's get started. The first question is asking me to differentiate this. Y is equal to sine inverse of 5x. Alright, now the 2 shouldn't really bother you because it's a multiplied constant, so it's going to stay the same. Now this one, you can look at it straight out of your standard integral table. Yes, it's an integral table, but you can use the reverse to differentiate. So just remember this 5 over here, you can treat that as having this 5x, sorry, you can treat this as being x divided by 1 on 5. Right? So once you realize this is pretty straightforward. So what we're going to have is 1 on square root of 1 on 5 squared, so it's going to become 1 on 25 minus x squared. Okay, so that's pretty much your answer. Now it's best to simplify this a bit, so I can rewrite this as going 2 divided by everything on 25, 1 minus 25x squared, right? And this 25 I can bring out front, so it's going to become 1 on 5, and therefore we're going to end up with the answer 10 on square root of 1 minus 25x squared. Okay, so that's my answer. Okay, part B. So now we're running into what do you call this, binomial expansions. Part B. So we got this expression 2x minus 1 on x squared all to the power of 12. Now they want to find the term that has the that's expansion is independent of x. Okay, so I need to find the term that is independent of x in this thing. Right? So let's do this. Okay, I'm going to start writing off the first few terms. So it's equal to, the first term is going to be 12 choose 0, and then it's going to be 2x to the power of 12, and then I mean this doesn't really make a difference, but I'm going to write it anyway, minus 1 on x squared to the power of 0. Okay, the second term is going to be 12 choose 1, 2x to the power of 11, and then minus 1 on x squared, so this minus is really important, minus 1 on x squared to the power of 1, and dot dot dot. I'm just going to write the nth term is going to be 12 choose n, 2x squared, sorry, 2x to the power of 12 minus n. Okay, so it's important to remember it's 12 minus n, not n, and then it'll be minus 1 on x squared to the power of n. Okay, I don't really bother with the last term, but anyway, this is the one that I was really after. Okay, so this one. So I need to find out when does this cancel out with this x squared, right? Okay, so let me write down. So I'm not going to worry about any of the constants. I'm just going to worry about just the x's. So in a general term, I will have x to the power of 12 minus n multiplied by, now this x squared to the n, I can write 1 on x to the 2n, right? Okay, so simplifying this is the same as x to the 12 minus 3n, because remember this 2n I can write it as x to the minus 2n. Okay, so I need to find out when does 12 minus 3n equal to 0, and the answer is when n equals 4. Okay, so when n equals 4, I have the term that's independent of x. So coming back to this, right? So now I'm going to write out the actual term. I'm going to worry about the constants. So it's going to be 12 choose 4, 2 to the, so 12 minus n is going to be 2 to the 8 multiplied by minus 1 to the power of 4. So we know that this is going to become 1. So the final answer is 12 choose 4, 256. And I think it's good enough to leave it as it is. You don't really need to plug it in your calculator. Okay. All right. C, more differentiation. All right. So the question goes: y is equal to e to the 3x cos x minus 3 sin x. So how do I differentiate this? Now, you need to remember your product rule, all right? So because that's one term, that's the other term. All right, so y dash, so differentiating this one first, it's going to become 3e to the 3x, and then you leave this one alone, leave the second one alone. So I end up with cos x minus 3 sin x. But now, remember, I still need to add up what I didn't differentiate, so I leave e to the 3x alone, and I differentiate this part, and I get minus sin x minus 3 cos x. Right, so now if you can see, there should be some equivalent terms, right? So I'm going to collect everything, collect the like terms. So I'm going to write 3 e to the 3x. So instead of writing cos x all over again, I'm just going to write c, and then minus 9 e to the 3x s plus, sorry, it should be a minus because I can take the minus outside, so it's going to become e to the 3x s, and then plus, sorry, again, it's my mistake, 3e to the 3x cos. Alright, now if you look at these two, that term and that term should cancel out. I will end up with minus 10e to the 3x sin x. So the last one, don't write s, make sure you write sin x. Okay, so there we go. All right, using this, the second part of that question is saying, using this fact, integrate this. Integrate e to the 3x sin x, of course, dx. All right, so if you look at this, if you look at this term and that term, what we're missing is a minus 10. So what I'm going to do is I'm going to introduce that minus 10. And remember, in maths you can't just introduce terms without getting rid of it. So I need to go 1 on minus 10. Okay, so now that I know that those two are the same, I can simply write out this part of this part up here. Okay, so that's going to be our answer. So this is equal to minus 1 on 10 times e to the 3x cos x minus 3 sin x. So what we were originally asked to differentiate, right? And of course, don't forget your plus c. Okay, last question, D. Now they give you this dt, okay, so the capital T stands for temperature and the small t is for time, is equal to minus k t minus 3. What they're asking you to do is to prove that t equals 3 plus ae to the minus kt is a solution to this. Okay, now the hard way of going about this is to actually integrate this to get to this point, but since they've given you this and they say that's actually a solution, all you need to do is differentiate this one. All right, so if you differentiate that, that's enough to show this. All right, and remember, it's just 1 mark, so that's all you need to do. So differentiating dt with respect to time, I get, so the 3 goes away, it's going to be a times, okay, sorry, I'll start off with, so it's going to be, so when I differentiate minus kt, I get minus k, right? So I get minus k times ae to the minus kt, right? So that's what I get when I differentiate, right? Now if you look at this term, that's exactly the same as this, isn't it? So rearranging So I can do this. T minus 3 is equal to AE to the minus KT. Now I can plug in this thing into here. Okay, so I will end up getting dt d time is equal to minus k times t minus 3. Okay, so that's the first part of the question. Part 2. Okay, part 2 of the question is actually asking you to solve for a and minus k, and then there's a bit more. But okay, let me write down what they're asking you to do. So they give you this set of data initially. So they say initially the temperature is 25. So the word initially is a key word because it means t equals 0. My temperature is 25. When the time is let me see, they tell you that when in 10 minutes it cools down to 11 degrees. And what they're asking you is in 15 minutes what would the temperature be? So what is the temperature in 15 minutes? All right, okay, let's get started. So plugging in the initial data, what I'm going to have is 25, the temperature, is equal to 3 plus a e to the 0. So e to the, because minus kt, so t is 0. E to the 0, remember, is 1. Anything to the power of 0 is 1. So all I have is 3 plus a. And this means a is equal to 22. Okay, so that was easy. The next one, when the temperature is 11, time is 10. So I have 3 plus, now I can sub in 22 now, e to the minus 10k. Okay, so I'm going to rearrange this to get what k is. So 8 on 22 is equal to e to the minus 10k, and k, minus 10k is equal to ln of 8 on 22. Okay, now it's probably a good idea to leave it as it is, but if you really want, you can just you can use this to say k is equal to minus 1 on 10 ln of 8 on 22, so which you can simplify to be 4 on 11. Okay, and then plug it in your calculator and get what the value is. But anyway, there's a smarter way of going about doing this. I'll come back to this. The smarter way. Okay, so now what they're asking you is what happens in 15 minutes. So t is equal to 3 plus 22 e to the minus 15k. Alright, so I'm not about writing what k is, right? I'm going to assume you saved it in your calculator. All you do is just plug it in. The smart way that I was talking about was to realize that this minus 10k, if I multiply this by 3 on 2, if I multiply this part by 3 on 2, that gives me minus 15k, right? Obviously I need to multiply this side by 3 on 2 as well. Okay, so if you realize that minus 15k is actually equal to 3 on 2 ln 4 on 11, right? Which is also the same as ln of 4 on 11 to the power of 3 on 2. Now I can plug this in here, right? And what happens with e and ln? They cancel off. Ln and e, or e to the ln or ln of e, they cancel each other out. And then you end up with whatever's inside the brackets. Right, so my actual temperature is equal to 3 plus 22 times 4 on 11 to the power of 3 on 2. Okay, and yeah, so this will be, so it'll be 3 plus, okay, so I guess this was unnecessary considering the amount of time it's taking, but I'll just show you why it gives you a nicer answer. So the bottom will be 11 root 11, the top will be 8. Okay, so 4 root 4, which is 8. Okay, now the 11 and the 22, they cancel out to give me 2, and what I end up with is 3 plus 16 on root 11. Okay, so that's my answer. So either way, it should be fine. Even if you got a decimal, I think you'll get full marks. So anyway, that's question 2. So if you have any questions or comments, please let me know, and it would be great if you can rate the video as well. But thank you.